call is now being recorded.
So we are going to look at page 242 in the notes and learning how to identify the number of significant figures. So significant figures is a set of rules of how scientists and engineers look at written numbers and consistently write down the written numbers in the same manner so that our quantitative information and records are as consistent between scientists and engineers around the world. So, significant figures are defined as all of the readable or known digits on an instrument scale plus one uncertain or estimated digit. So, the most right significant figure is always the estimated digit, and we can place a bar above that digit to represent that it's estimated or uncertain. And the place of estimation, whether it's in the tens, the ones, the tenths, the hundreds, the thousands, okay, so the place of estimation represents the precision and accuracy of the measurement. So, what we're going to do first is learn how to look at a measurement that's recorded and identify the number of significant figures. My method of identifying this is looking at this simple set of rules. And the big thing is learning when are zeros significant or when are zeros simply placeholders. So first thing, all written non-zero digits, so digits 1 through 9, are considered significant. Trap zeros are always significant. So that means to the left of that zero, there's a non-zero digit like a 1, 2, 3, or 4, and then also to the right of it, there's a non-zero digit. So trap zeros are always significant. Leading zeros, so they start off the number on the left, are placeholders. So these guys are never significant. So they are never considered significant figures. The trick, so trapped are always significant, leading are never, and where it takes practice are those trailing zeros, zeros to the right of the decimal place. So trailing zeros can be significant. So they are significant if a decimal point is actually written in the number, whereas trailing zeros are placeholders if there's no decimal point written. So that means if they're placeholders, then they are not part of the significant figure count. So what we're going to do is go through some examples down here at the bottom, just paying attention to the zeros and coming up with the number of significant figures. So my first measurement is 100 centimeters. And when I take a look at this, the only non-zero digit is the 1. And these zeros right here, because they're to the right of my non-zero digit, they are considered trailing. And because so they're trailing zeros. And if they're trailing zeros, I have to look at the number. Is there a decimal written or no decimal? So these are trailing zeros. It's written as 100 and there is no decimal. So they're trailing and there is no decimal. So they are not significant. So I'm going to underline in green the significant digits. And in this case, it's only the only significant figure is the 1. So the number of sig figs in 100 centimeters as written is one significant figure. Now, taking a look at the next value that's written, it's also 100 centimeters. So these two zeros are trailing behind the non-zero digit, so they are trailing. But when I look at the way that this number is written, it's 100 decimal point, but there is a decimal. So in this case, okay, the non-zero digit of 1 and the trailing zeros, because of the decimal point, are considered significant. So now, look at, I underlined 3 digits. So this number has 3 significant figures. Moving on to the next measurement. So this next measurement, if I was just to read the value, I would say 1 centimeter. But in the way this value is written, there are these zeros, and they are to the right of the only non-zero digit. So once again, these are considered trailing zeros. Now, trailing zeros could be placeholders or they could be significant digits. It all depends on if there's a decimal showing in the number. And this one, it's 1.000. So they're trailing, but there is a decimal. And because there is a decimal, those trailing zeros are considered significant. So I underline the trailing zeros plus the non-zero digits. So the number of digits I've underlined is 1, 2, 3, and 4. So there are 4 significant digits in the way that the 1 centimeter is written down. Okay, so now we have this next value. And so sometimes instead of putting commas in numbers, we leave a small space between groupings of 3. So this would read 101,000 centimeters. And so I have some zeros here. So first off, there is this 0 that is trapped between this non-zero digit and this other non-zero digit. So it is trapped. And because it's trapped, it is definitely significant. Trapped zeros are always significant. But then I take a look at the other set of zeros. They are to the right of the last non-zero digit. So these guys are trailing. But the way that this number, 101,000 centimeters, there is no decimal. And because there is no decimal, these are not significant. So underlining, it's the non-zero digits and the trapped 0. These are the only significant digits. And because of that, there are only 3 sig figs in this measurement. Last example here. Okay, so I take a look. Here is my only non-zero digit. And notice there are zeros that come before it. So the zeros that come before it, these are considered leading zeros. So they start the number off. Leading zeros are never significant. So they are not significant. But I take a look at my non-zero digit, and right here, there is this 1 0 that is to the right of the non-zero digit. And so this is a trailing 0. Now I have to ask myself, this trailing 0, is it significant or not significant? There is a decimal that's written in the number, so this trailing 0 is considered significant. So when I underline the significant digits, it is the only non-zero digit plus the trailing 0. So there are 2 significant figures or digits in this number. Okay? So practicing that rule. Is it trapped? Always significant. Trailing with a decimal? Always significant. Leading? Never significant. Trailing? No decimal? Not significant. Okay, so now the place of estimation. So I want to go first all the way back, or first I want to go back to rule. Where do I? I'm going to come back up here. Okay, so point number 2. The most right significant figure is always the estimated digit. So the most right significant figure is always the estimated digit, and we place a bar above it. So I want to do that next here. Okay, so this is part B. Place a bar above the estimated uncertain digit. So I'm going to change my color to red here. Okay, so I take a look I'm going to go down to number 2 here, 100 centimeters with a decimal. So I take a look at what I underlined in green. There are 3 significant digits. The digit most to the right is the estimated. So I'm going to put my bar above it. I'm going to go back up to the top one, 100 centimeters, no decimal point, right? The only digit underlined in green is the only significant figure, and therefore it's the most right one, so it gets the bar of estimation. Moving down to 1.000. All 4 digits are significant. So I start to the left and I find the significant figure, the one that's underlined in green most to the right. That's my estimated digit. And so I'm going to put a bar above it. Next to last example, 101,000 centimeters. There are 6 digits written in the number, but only the 101 are the significant digits. So I find the one that's the most to the right of it, and I put my bar above that. So that is the estimated or uncertain digit. Last example, the 0.010 centimeters. Only these 2 digits, the one with the trailing 0, are considered significant, so I underline them in green. And the one that's more to the right is my significant figure, so it gets the bar above it. Now, the position where we put the bar above it, okay, step C wants us to name the place of estimation. So I want to go all the way back up to the top of the page. I left this for now. So naming the decimal places, you probably know these, but we're going to review it. So we're going to start with the decimal point. The first position to the left of the decimal point, you already know it designates the value position of 1. If you move one more position to the left, now you start to get into the values of tens. All right. You have $1, $2, $3, $4, $5. Now you move up $10, $20, $30, $40. Moving up or moving back one more position to the left, it represents the position value of the hundreds. So the hundreds, 100, 200, 300, and one more, we'll work with one more to the left, would be the thousands. Now, back to the decimal point. Moving to the right of the decimal, okay, the first decimal position to the right of the decimal, it is the tenths with a TH. Continuing one more position to the right would be the hundredths. And then we'll just go one more position to the right is the thousandths. So now what we need to do is take a look at the place of estimation. This is the value, okay? This is where we place the bar. So this is the digit with the bar. So the digit with the bar above it represents the place of estimation or the uncertain digit. So now take a look at it. So we have our value of 100 centimeters. There's no decimal, but we understand that the decimal, if written, would be sandwiched between our most right 0 and the unit of centimeters. And so we take a look. The digit with the bar above it is 1, 2, 3. 3 positions to the left of the decimal. So if I go up, back up to the top, here's my decimal. 3 positions to the left. My estimated digit is in the place of the hundreds. So my estimated digit, so I estimated in the hundreds. Whereas you look at the next value, 100 centimeters with the decimal, the position that the digit with the bar above it is 1 place to the left of the decimal. So if I go back up to the top, here's my decimal, one position to the left of it puts me in the ones spot. So my place of estimation here is in the ones. If I take a look at the next example, 1.000 centimeters, the digit with the red bar above it, it's 3 positions to the right of the decimal. So if I move back to the top, I find my decimal and I go 3 positions to the right. Now my place of estimation occurred in the thousandths. Taking a look at the value 101,000 centimeters, the 1 that has the bar above it, I understand my decimal would be here. So it is 1, 2, 3, 4. It is 4 positions to the left of the decimal point. So go back to the top. I find my decimal and I move 4 positions to the left. 1, 2, 3, 4. Oops. And so now it is my place of estimation is in the thousands. So not the thousandths, but the thousands. And the last example, I take a look at 0.010, the estimated digits, the one with the red bar above it, and it's 1, 2, 3, 3 positions to the right of the decimal. So here's my decimal, 1, 2, 3, and that estimated digit is in the thousandths. So your job now is to move on to page 243 and to do the you do section up at the top, following using the rules to first identify the number of sig figs, underline the sig figs, and then identify how many digits you included in the sig fig count, put a bar above the estimated digit, and then name the value position of that place of estimation.